Alright, hey guys, and welcome back to basically another entry in this series about building a CPU from pretty much basic logic gates in Logisim. So the next sort of step that we've got to take before building the full ALU is that we kind of want to go ahead and look at what would be specifically the sort of logical operations that you can perform on a bunch of bits, right? So there's obviously these different gates that we have, and, or, not, and XOR, which are the principal ones that we're going to be looking at. And we're also going to be building a negate, which is basically 2's complement, to make a negative number, at least a negative number representation. But when we're looking at all these different things, if you look at like an AND gate, you can bring up these numbers of inputs and these numbers of data bits. So you could have basically 2 inputs of 32 bits and stuff like that. That works pretty well, and it's actually probably a valid solution to the problem, but I just want to go ahead and take a small look at the way that we would build them from the more basic gates in order to actually go ahead and handle this, since we're trying to stay with pretty much the minimum number, starting with just a single bit. So if we want to go ahead and add a circuit for basically the ALU and for 8 bits, I'm not going to do a 1 bit because obviously we already have that. So let's do ALU and 8 bits, and let's go ahead and do that. So to take an AND of 8 bits, actually, I should name it differently. I should name it ALU and then 8B, or 8B and. Just to follow a naming convention, of course. So we're obviously going to have this AND input, so a single input into an and then a single output of the two A and B. Now, to do an overall AND for 8 bits, we're going to have to actually go ahead and each individual byte, or each individual bit, and then each output of the 2 bits is going to be reflected as a result. So we're going to go ahead and start with a pin. The pin should have 8 bits, and we're going to have it start off 1. One here is A, and then another one is going to be B. So we take A, and then we take B. We're going to take a splitter. Splitter is going to split and fan out into 8 different little things here from all 8 bits. If we take that, we're going to go here, and then we have our different inputs. We can go ahead and do a copy of this, bring it down here, make it right-handed, and then we're going to do the same thing with the B. So we're going to go ahead and basically take a series here and make a series of 8 AND gates, and then we're going to go ahead and center this upon the middle of these AND gates. And now that we have done that, we're going to go ahead and bring it over the first bits all the way over to our respective inputs. So we're going to take A from each one and build them out like so. Now we're actually going to have to go ahead and, we're going to have to move them over. And to do so, I should probably allocate enough space such that we don't run into issues with the length when we cross them over. Now, I should probably actually start that by going all the way across here to go ahead and get to the gate that we want to do. We're going to do the bottom one as sort of the interior side. So we're going to do that. Then we can go ahead and do this. And then bring this one over and across. This one over and across the right spot. And then finally this one goes over and across. and I was off by 1 on the initial one, so I'll go ahead and fix that. So pretty much location, 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 right? I'm going to take it over here and bring it there. So now we have our 8 inputs to the entire AND group here. Then we're going to go ahead and go across and go and bring ourselves some of these outputs here. So this should go to bit 4. Goes there. I might need to make some space here for bit. Wait, is this bit? This is bit 4. I would need to bring this across to here and then over to here. So it becomes an issue with overall just what does the circuit have to look like in general. It's kind of just complicated, and if you think it out beforehand, it probably ends up looking a lot nicer than whatever I'm about to create here. Right? And then we're going to just go ahead and bring this across. Then this across to here. Now the rest of it, we need to shift back a little bit in order to go ahead and properly be able to make use of it. So we're going to go ahead and take this out and over. I'm off by 1. Out and over. And do the same thing here to basically wrap in all the rest of them. Goes across here, across to there. This goes across to here, and all the way out to here. And this goes across here. Oops. All the way across to here. And we're going to go ahead and take all of these and pretty much shift them back until we don't have any conflicts. Now, I should probably make this even as well. So we're just going to move these to be somewhat even like that. So then what we got to do for the end result is we're going to take a splitter, throw it to face west, and then we're just going to composite the results of the entire thing. Simply. Oops. Don't tie them together. Take the results here, and we're going to go ahead and do the same thing over. Oops, not to there. Yeah, don't mess up the bits. That's a big issue. We're going to bring it over and into here. We're going to bring one down a bit, and then we're going to bring it over here and do it like that. This way we can go ahead and do all the comparisons that we need. And then, there we go. We go ahead, take another pin. We're going to face it west. Pin. Face it west. Text on the east side. It's going to be the result. And then we're going to have our output as yes, and then we're going to just attach it up here, and here we go. We have a very basic 8-bit and this can do the ANDing operation for 8 bits. Next thing that we can go ahead and do is we can go ahead and do the same exact stuff for OR, XOR, and all of that, and it becomes actually really simple because now that we have this circuit design, we just gotta change the type of gate. So it's ALU 8-bit OR. So if we want to do ALU 8-bit OR, we take this, and then we're just going to go ahead and take all of the gates in the middle and just replace them with a different gate. So in this case, OR. Our ORs should always be 2 bits. And then output 0, 1. And here's our OR gate. So we're going to take the OR gates and we're just going to throw them in to the right positions. And we will have a nice and working version of what we want. So throw that in here, and then we're going to go ahead and take it here. Wow, now we have an 8-bit OR. Great, and then we can do a NOT and an XOR. So ALU 8-bit XOR take, which is pretty simple. Take our OR gate, throw it into XOR, and then we're going to go ahead and replace the gates with XOR. So just go take it down the middle. Once again, take XOR. Actually, sorry, the actual XOR gate. There we go. Take that. It is a bit longer. That's interesting. I didn't think about that. That's interesting. So they are one little bit longer. That shouldn't hurt us, I don't believe. Gonna make it look interesting. Let's go ahead and take this and copy it. This there. I forgot that technically I can just copy 2 of them and it would work too. So that works. It looks a little silly, but no one is really going to rag on you too much for doing that. And then we're going to go ahead and make the ALU 8-bit NOT gate. This is actually slightly different because all we're going to take in for a NOT is that we're going to have to only take in the A input side. So I have to go ahead and take that into here. And instead of this whole complicated mess of wires, it actually becomes almost stupidly simple to do, to the point of which I feel like it's going to be pretty easy to go ahead, take the wiring, take a splitter, face this to the west side. Cool. Couple the two, or actually before we couple the two, we're going to go ahead and take a NOT gate and throw a NOT gate onto every single member here, which, by the way, can just fit together all as one. So that makes it pretty easy to do. We're going to take the NOT gate, connect them to the connect it to the outputs, and then we're going to pretty much go ahead and create an output pin, which is going to be output yes facing west with the label R on east. I did not want to change the font. I don't really see much point to changing the font, so yeah. And then cool, now we have our NOT gate for that. And the next things that we can go ahead and do, pretty simple. Let's go ahead and do the wire diagrams. It's not that hard. We're just going to go ahead and separate them out by 1 and move these over here to these small little units, and we're going to call it 8B and. Is that the same? Yeah, 8B and. So that looks fine. Next thing we're going to do, make a little thing here. Pretty simple. Pretty simple to make these little modules. And they're going to be used inside of the ALU for purposes like that. Let's go ahead and move this up a little bit. Like so. Resize it. And throw these down here. So I have 8B OR, so it's going to be 8B OR. Then we go ahead and do the same thing here. Resize the box in order to be a 3 by 3. This is by 3. Okay, and then throw the little thing here and bring this down 1. Boom. Now we have this nice little thing here that should be aligned. And then there we go. And then we're just going to call it 8B XOR. Same logic goes ahead for the 8-bit NOT. This is actually fine the way it is right now, so I'm just going to say it's going to be 8B NOT. Now that we have all these smaller versions of them, then we can go ahead and do the 16-bit version and the 32-bit version, which I'll just do off screen because now you get the same idea. It becomes the same exact thing as the 8-bit full adder. I'll do one just for an example, and then I'll go ahead and just do the rest myself. So we're going to take ALU, ALU 16-bit, and then AND. So we're going to take ALU 16-bit AND. Pretty much, we're going to take two ANDs, run them together like that. Take a wire for the splitter, fan out to 2 with bit width of 16. And then we're going to take this, take a 16-bit input, and then we're going to go ahead and have this be our A. Then take the second one, have this one be our B, not V, B. And then all we need to do is split this off. Oops. And then connect it to top of an 8-bit AND. Take the second one here. We're going to split it off on the opposite side, of course, so right-handed. And then we're going to take it to here. Bring it down one. There we go. Then we're going to go here. And bring this up to down here. And bring this one across to over here. Nice little crisscross, I guess. Then we're going to take another splitter. Place it west side. Put it in the middle. Top side. Bring it down. Bring it across. And then do the same thing for the bottom side, and then we're going to just go ahead and create an output pin facing west, output, yes, and then call it results R, facing on the east side, go into here, and then we can go ahead and test the AND. So if one is true here and not true there, it's not going to be on. If 1 and 1 are true, then of course it's going to work. And it's pretty much as you would expect. Top bits will also work perfectly, and it's pretty simple. So this is going to be our basic 16-bit AND as well. So just going to scale it up a little, throw the two things down here, and then boom, now we have our 16-bit AND. Then you pretty much do the exact same process for all of the other ones. And then 32-bit is the same as a 16-bit, so ALU 32-bit AND is going to be this. Take it over here, replace the 8 bits with the 16 bits. What's the issue? Oh, there's going to be one other issue, is that the splitter needs to be now for 32 bits. And the inputs need to be 32 bits. So take this one to be 32 bits. It's going to need to be 32 bits here. And it will warn you pretty much for all of this. What's the issue? There's no issue there. Okay. And then take this one here and have a bit width of 32 and output of 32 as well. Well, I want to go ahead and just make it a little easier to look at by moving these all down a bit. There we go. And then I can move the central part here. Oops. Down into the middle as well. 32 to 23. Oh, I did a 23 thing instead of 32. Boom. And then there we go. Now we have the 32-bit version of it with the 216 bits. So pretty much I would just go ahead and repeat that for OR, XOR, and then repeat the NOT for NOT. So either way, this is going to be the end of the tutorial. And in the next episode, I'll have all of the 16 and 32-bit versions of that. And we can start working on doing negate. And then we should also be able to do the rest of the ALU.